So, very good evening to all my dear students. Myself, Dr. Namami Krishna Sharma, and I am working as an associate professor. I have total more than 12 years of teaching experience in electrical engineering field. I did MTech and PhD in electrical engineering, and here I will facilitate you to prepare for SPSE examination, that is Assistant Engineer for Electrical Engineering. So let's start from the examination strategy. First of all, you should know what is the examination pattern. Then we will plan accordingly for which topic we have to give how much of time. So there are two sections in the paper. First is the non-text section, that is 100 marks, and second one is the technical section, that is 300 of marks. So in this our meeting, we will focus on our second section, that is technical section, which is total 300 of marks. And this is a very important exam. And you can see here in the later in this video we will see the question paper of last year. The question paper is divided into two sections. First one is 75 questions of MCQ type, then remaining questions are descriptive type. So let's start. You can see that the total questions, there are 87 questions including MCQ question as well as descriptive type question. Amongst 87 questions, the 75 questions are MCQ type and 17 questions are descriptive type. Negative marking is there for MCQ type of question, that is 1/3, and total number of MCQ questions are 75, 2 marks each. In this way, the total marks for MCQs are 150. Let's come to the second section, that is descriptive type questions. So descriptive type questions are divided into three subsections: Section A, Section B, Section C. Section A includes 5 marks question, means there are 10 questions of 5 marks. That is total 50 marks, and there is an internal choice, means there are 11 questions and you have to attend only 10 questions. Similarly, in section B, there are again 10 mark questions. Total number of questions are 5. In this way, total marks are 50. And here are also you will get 2 internal choice questions, means you have to attend 5 questions out of 7 questions. In section C, you need to attend only 2 questions, 25 marks of each, and it is total 50 marks. So 50, 50, 50 means 150 marks of descriptive type questions and 150 marks of MCQ type of question. Very interesting examination pattern is this. Now let us discuss about the syllabus and weightage, because I have gone through the last year question papers and I did some analysis based on MCQ type of questions and descriptive type of questions. So we will discuss one by one as the subject comes. So starting from basics of electrical engineering, this is very basic subject of electrical engineering. It includes DC circuits, magnetic circuits, single phase AC circuits, 3-phase AC circuits. So you can see here 26 plus 5 means 26 marks are of questions from MCQ type and only 5 marks from descriptive type. So total 31 means weightage of this BEE subject is 31 out of 300. Okay. From the last year question paper I have written down this. Similarly, the second subject is network theory. Network theory includes KVL, KCL, phasor calculations, transient and steady state response, graph theory, network theorem, two-port networks, resonance. Means we can say this is the extension of basic electrical engineering. And you can see 10 plus 20, 10 marks MCQ type questions and 20 marks descriptive type question. Total marks 30, means 10% of 300, that is 30. Okay. Then number 3, it is electrical machine, very important subject of electrical engineering. That is, it includes DC machines, AC machines, transformers, synchronous machine, induction machines, 3-phase induction machines, single phase induction machine, special purpose machines, and electromechanical energy conversion system. So you can see 8 plus 5, 8 MCQ and 5 marks descriptive, total 13. Power systems. So this is the very vast subject of electrical engineering. During our graduation, we complete power system in 3 or 4 parts: power system 1, power system 2, power system 3, then power system protection, then switch gear and control and all. So power system is very vast and it includes transmission line performance, compensation techniques, voltage profile control, distribution systems, cables and insulators, economic power generation and load dispatch, fault analysis, stability, protection, load flow studies, high voltage transmission, per unit system, power system transients. So this is total 65. Its weightage is 65 marks out of 300. Means 10 marks from MCQs and 55 marks. You can see here 55 marks from descriptive type of question. Very important subject, power system. Similarly, control system. Very interesting subject as far as GATE is concerned. So control system includes mathematical modeling, feedback characteristic of control system, time response, frequency response, stability, root locus, Bode plot, Nyquist plot, frequency response, design of control system, state variable analysis, and its weightage is 57 means 12 plus 45, 12 MCQ and 45 descriptive type question. Subject number 6 is electrical and electronics measurement. Means here you will see how ammeter, voltmeter, wattmeter works, galvanometer type instruments and other type of instruments. We will see electrical instruments, electronic instruments, measurement of resistance, bridges, AC bridges, measurement of energy, measurement of power, and electronic measurement instrument transformers, means CT and PT. Its weightage is again 31, nearly 10% of 300, 16 MCQ and 15 descriptive type questions. Analog electronics. Analog electronics is again very important subjects. We can see the syllabus includes basic electronics engineering, means diode and their applications, BJT, FET, their biasing circuits, small signal analysis, operational amplifier, very important, operational amplifier. A lot of questions come from operational amplifier topic. Oscillators and feedback amplifiers. The total weightage is 20, 10 plus 10, 10 MCQ, 10 descriptive. Next subject is digital electronics, 0110, logic gates, sequence circuit, combinational circuits, analog to digital converter, digital to analog converter, logic families, universal gates. So its weightage is 16, 6 MCQ, 6 marks MCQ and 10 marks descriptive type question. Power electronics, again one of the very important subject of electrical engineering. Power electronics includes power semiconductor devices and their characteristics, their commutation techniques, phase control, rectifiers, converters, choppers, inverters, drives. So its weightage is 35 marks out of 300, 20 marks MCQ and 15 marks descriptive type of question. And the last one is electromagnetic theory, mathematical kind of subject. And here you can see the coordinate system, spherical coordinate system, cylindrical coordinate system, rectangular coordinate system, electrostatic field, magnetostatic field, and EM waves. So total weightage is 35 marks, 20 MCQ and 15 descriptive. So this is overview of your syllabus in short. Important topics we have covered. You can see total 10 subjects and the weightage of 10 subjects are nearly equal, or 2 subjects are having higher weightage like control system and power systems. So we will focus these subjects accordingly. Now, how you should prepare for this examination? As far as I am concerned, I have qualified various competitive examinations, GATEs and other prestigious examinations several times. So what I have observed for this examination, what should be your preparation strategy? So I have prepared this preparation strategy in very short. During the course of time, we will discuss in very descriptive manner also. So first one is theoretical, analytical and conceptual learning. Because why I am saying theoretical? Because descriptive type questions are also there, and as we have faced the question in our university examinations, engineering services examination, state engineering services examination. That's why we need to cover all the theoretical aspects of important subjects, important topics. Analytical means MCQs are analytical type. None of the MCQs are theoretical type. Most of the MCQs are numerical type. That's why we need some analytical approach. Conceptual learning. Without knowing the concept of all the topics, you cannot solve any one question. The questions are not simple. They are very tricky. Either they are from GATE point of view, either they are lie in the GATE category, or they lies on the ESE category. All the categories are important and interesting. That's why theoretical, analytical and conceptual learning of all topics in crisp form. We are not going to read, we are not going to cover whole book, like for analog electronics, Boyle stat, for power systems, any, like let's say CL Wadhwa or TP Kothari for electrical machines, Bhimra and Fitzgerald in crisp form. So I will provide the notes in the crisp form. So this is the strategy number 1. Strategy number 2, after learning all these aspects on topic wise topic, we will solve some MCQs of gate level. We will solve some MCQs of ESE level, and after solving this MCQ of particular type topic, I will provide you the practice MCQ, and just after 2 days I will solve all those practice MCQs with you, and you can compare your answer with mine. So definitely your answers and mine will be matching after the completion of any topic, because we have given we will give much of the time in the solving sessions. Okay, and the step number 4 is, next step is practicing MCQ. Okay, practicing MCQ level wise on all topic of all subjects, then solving descriptive type questions of reference books. This is my personal opinion, because I have gone through the paper of last year. What I have seen, either the questions are as it is from reference book. Let's say for power system, why I am talking about power system, because total weightage was 65 nearly. Most of the questions are from either from the CL Wadhwa or any other reference book, standard book. And similarly, solving descriptive type questions of reference book, as well as last year questions of ESE, Engineering Services Examination, descriptive type questions, and state PSCs of various states like Madhya Pradesh and Chhattisgarh, Uttar Pradesh, other northeast states, Delhi. So they are also offering their state engineering services, and they used to, the descriptive type of question used to come in these examinations also. Then practice descriptive type questions subject wise. Okay, so descriptive type questions are very not lies on the very higher category. They are very simple. If you know the formula, you can solve the question. But MCQ type of questions are tricky. You have to apply various concepts, various analytical skills. So this is the preparation strategy in very short. In the course of time, we will discuss this preparation strategy in detail also. And now this is your sample question paper of last year. This is Sikkim Public Service Commission, Electrical Engineering. Okay, so these are the important instructions. I think you all might have gone through this paper. What I have observed, I have written the subject wise, like question number 1 is from maths, 2 is from maths, 3 is from maths, and 4 is from maths. So you just see the pattern, how the question comes from different subjects. Okay, 4 questions from math and in the serial 1, 2, 3, 4, no issue. Question number 5, network. Question number 6, also network. Question number 7, also network. Question number 8, network. Question number 9, network. Okay, so what I am trying to convey, if MCQs are dominant, then their descriptive portion will be lagging. Means, let's say if 16 marks of MCQ from network analysis, then definitely you will find less question of network in the descriptive session. This I have observed from this question paper. Like question number 10 is analog electronics, analog electronics, analog electronics, analog electronics, analog electronics. So total you can see 6 questions, 6 into 2, that is 12 marks. Then digital electronics. So all these questions are either they are from GATE category or they are from ESE category. So we have to cover both, and they are not very tough. They are under our approach. They will be under our approach after the completion of the topics. Question number 18, very simple. From this block diagram, you have to find out the equivalent block diagram of this particular circuit. So this is control system, control system. Then measurement. So I have gone through this paper, then I have prepared that table. Okay, power electronics is also very important subject. We will discuss this subject in very detail also. And this is n number of questions from power electronics. Then power system. Here comes the power system. Let's say this question, just read it for sample only. 36. For protection of parallel feeder fed from one end, the relays required are non-directional relays at both ends, directional relays at source, and non-directional relays at load, directional relays at both ends. So this is the conceptual type of question. Just read the question, then tick the correct options, because what is written, for protection of parallel feeder fed from one end, the generator is at one end, the load is at one end. So we will decide the answer accordingly after the completion of this topic. Okay, Then this is again the power system. From the power system, this is corona loss. So you can find several questions in the back side of CL Vatva also. This I have also observed. This is from power electronics, power system. So I request all the participants to go through all the last year question papers. This is EMT, electromagnetic theory. Your imagination will be very, your imagination should be very strong for covering this question, because we have to deal with coordinate system, spherical. The point is located in this domain, the charge is traveling in this line, and the surface is lying on the XY plane. Then what will be the electric field intensity at XYZ? So your imagination will be should be very strong, so that you can solve easily the EMT questions. And these questions are also the tricky questions. This question is from electrical machines, material, electrical machines, BEE. Very simple questions. Resistivity of wire depends on length, material, cross-sectional area, none of the above. So resistivity, you have the formula R is equal to rho L upon A, where rho is the resistivity. So you can write the formula for resistivity, that R into A upon L, and accordingly you can find the answer. So we will discuss all these topics in our BEE subject. And the charge, what the charge is located, then how many electrons, means what is the current, that is the charge per unit time. So from that formula we can solve this question. Okay, this question is from BEE also. Very simple questions. Two aluminum conductor have equal lengths. This question is also lies under the formula of R is equal to rho L upon A. This is EMT, electromagnetic theory. This is from measurement. This is also from measurement, BEE. So you can see, I think 10 or more than that questions are from BEE. So definitely you will find lesser questions from BEE in the descriptive session. This is the difference. If the frequency of question in the MCQ section are high, then you will find less questions for that subject in the descriptive section. So this is 72, question number 72, BEE, and here comes the subjective paper. So as I have discussed, 3 sections, each 50. Section A, 10 questions, 5 marks each. Section B, 5 questions, 10 marks each. Section C, 2 questions, 25 marks each. So this is question, very simple questions. We used to solve this question during our UG preparation, university exam preparations. Okay, this is theoretical question like what are the basic components of wind energy conversion system? Draw the block diagram of wind energy conversion system. Okay, wind at 1 standard atmospheric pressure at 15 degrees Celsius at velocity of 15 meter per second. Calculate the total power density in the wind stream, the maximum optimal power in the optimal power density. So this question number 2 having 2 sections. One is the theory and another one is the numerical. Very simple formula used for this particular numerical. You have to put some constant values. You have to put these values and you will get the answers. Okay, this is electrical machine questions. Circulating current at no load, current supply by each transformers. Okay, 5 kVA, 500 kVA single phase transformer A. So we used to solve this type of questions. Okay, as I am the teacher, I teach in the college from last 10 years. So my second year students can solve this type of electrical machines transformer question in very few minutes. Okay. So this question number 4 is from power system. Again, R, L, C values are given. You have to find the efficiency regulation. You can find this type of question in the DP Kothari book, unit number 3 or 4. I don't know exactly number, but similar type of question you may find there. So nothing is tricky in this question. Just read the question, use the formula, solve the question, go forward. Simple. What is meant by accuracy and precision of instrument? This is again the question from measurement. This question is from digital and electronics, EMT, digital electronics, power electronics. Then section B, 10 marks question, little bit lengthy as compared to section A. This question is from switching, network analysis. This is from measurement and measurement subject. This is control system, EMT. And section C, you can see only 2 questions, 25 marks. Question number 19 from power system. It looks like very, lengthy question, but it is not up to that lengthy. You can solve it within few minutes. Okay, question number 21 is what? You have to draw only the Nyquist plot for this closed loop, for this transfer function only, open loop transfer function. So we have, so far we have discussed the question paper and how so you should prepare for this examination. Since this is our very first class, so we are starting our preparation from the as per syllabus, and the syllabus, our very first subject is BEEE, Basic Electrical Engineering. And what is the first topic? Let us see. So the first topic is DC circuits. DC circuits. So am I audible? I mean, my voice is still there, or I am disconnected, because I am not getting any response.
Yes, sir. You are audible.
Okay. Thank you. So let's start from the DC circuits. What do you understand by DC circuit, and which type of questions may arise in the examination? So very simple. I think you all are the graduates, and you may find this very easy for you. I don't know. So this is DC circuit. If I should start this particular topic, so what I should cover? First of all, what do you understand by DC? What are the characteristics of DC? What are the characteristics of DC, and how DC behaves? Okay, so let us start from the DC supply. The nature of DC means direct current. Direct current means irrespective of time, the magnitude of your electricity, the magnitude of voltage is constant. If you are saying, if you are saying voltage is 20 volt, so irrespective of any time, it will remain 20 volt. That is the property of DC. It does not having any fluctuation kind of thing. It does not having any frequency kind of thing. So our analysis is very simple. We not need to worry about its phasor position and all. So let us start from the very simple question. I am assuming that you all know how Ohm's law works. Like, let's say this is a battery of 20 volt. This is a battery of 20 volt connecting across a resistance of 5 ohm. Then what will be the current flowing through this 5 ohm resistor? Definitely this type of question will not come in the examination. What I am trying to convey in the next section, that's why I am discussing it. So I is equal to nothing but V upon R, and the voltage is 20 and the resistance is 5, so definitely the current will be 4 ampere. Now let us extend this question. Like, this is 5 ohm of resistor, and this is, let's say, 10 ohm of resistor, and the voltage source is same. So what should be your strategy for solving this question? What should be your strategy? Now we have three options. Either we can use nodal analysis, or we can use mesh analysis, or we can use current division approach, or we can find the equivalent resistance, then find the current. So that comes under the current division. No issue, that comes under the current division. Means we can solve this question from these three approaches. Now you should know which approach will be suitable for which type of questions. So we will discuss all these things. Let us again assume a different questions like this. If this type of question is there and you have to find the current in this branch, now again what strategy you can use here? So this question can also be solved by nodal or mesh or current division. Now tell me, anyone, if you know the star delta transformation is needed for this question or not? Anyone, just for interaction is only. Star delta transformation is needed for solving this question if I have to find the current for this branch. Okay, no issue, but it is very simple, so no need to use star delta transformation. But if the circuit is typical, then you should have all these types of approaches: nodal, mesh, current division, star delta. Then theorems are also important. So the first two subjects, the BEEE, that is basic electrical engineering plus network analysis, they are interlinked, they are related to each other, and we will cover the topic of network analysis in BEEE. We may cover the topic of BEEE in the network analysis. I consider these two subjects as a whole, as one. Okay. So our topic was DC circuits. DC circuits. So how I should start? Then DC, then current means voltage, current, then types of circuits. Types of circuits. Then approaches. What are the approaches? And here comes the syllabus basically. Nodal, mesh, theorems. So let us start. What is nodal analysis? Nodal analysis. Okay. So again, I am assuming a next question. Let's say some tricky question. 10 volt of battery, 5 ohm of resistance, 10 ohm resistance, minus plus 2 volt and 5 ohm. Now I am saying find the current in this branch. Find the current in this branch. So for solving this type of question, you may either use nodal or you may use mesh. So since we are discussing the nodal, so how nodal analysis can be applied for this question? Demo class, and for solving this nodal analysis, I am assuming you know KCL, KVL and Ohm's law, and in the course of time we will see in our notes all these topics in detail also. So we have to apply the KCL to this particular node number A. So let's say this is the incoming current I1, this is the incoming current I2, and this is the outgoing current I3. So incoming currents at node are what according to these directions are I1 plus I2, and the outgoing current are I3 only. So this is our KCL equation. This is our KCL equations at node A. This is our KCL equation at our node A, and you can see only one principal node is there, so no need to write further equations. Now discuss for this I1. Discuss for this I1. This I1 is originating from this battery. This I1 is originating from this battery and terminating to this node and terminating to this node. And you have assumed the node voltage at this node is VA. So you have to write the formula for I1, that is 10 minus VA upon 5. This is I1. Similarly for I2, you can see I2, this is I2. It is originating from where? It is originating from here, this node, reference node. What is the voltage of reference node? 0. So you can write 0 here. Then you can see the tendency of this battery. The tendency of this battery is to release the current from this plus terminal, but you have assumed the current from minus terminal. So you have to write the potential of this battery with minus sign, minus 2. Then minus VA upon what is the resistance? What is the value of resistance? This resistance is, let's say, 2 ohm. 2 ohm. Similarly, is equal to I3. I3 is equal to, this is your I3. This is your I3. So this is VA minus 0 upon 10. VA minus 0 upon 10. So this is a one equation, one unknown problem. In this equation, we can find the value of VA. In this equation, we can find the value of VA. And after finding the value of VA, what was the question? Question was to find the value of I3, and I3 will be VA upon 10. VA upon 10. Okay. So this is a very simple question, but what concepts we have used in this question? KCL, very important. Then how current flows like these type of circuits? What are the notations? Let's say there are two nodes A and B, and you have to write the equation for this current. Here the voltage is V, here the voltage is VB, this voltage is, let's say, 2 volt. What you will write for this current? Let's say in general I am writing VA minus 2 minus VB upon 2. Is it right or wrong? So we have to check it. So this is the concept we have used in nodal analysis. So before covering the nodal analysis, we will cover all these current directions. What we should write? VA minus VB minus V2 or plus V2. So you can for this particular question, you can observe for any case what you should know, the tendency of any battery. This is the symbol of battery. This is the symbol of battery. Battery is the source of electricity. This is our DC source. And the tendency of battery, this is the symbol of battery, and its tendency is to release the current. The tendency is to release the current from which terminal? Plus terminal or minus terminal? Plus terminal. If the current is releasing from the plus terminal of the battery, then battery is acting as a source for supplying that network. But here we can see this I is entering this battery from minus terminal and releasing from this battery from plus terminal. So now tell me, does the property of the battery violates or not? The property of the battery is to release the current from plus terminal. Same we are observing here. This is plus terminal. Current is releasing because this is a series circuit. This direction is same here only. So this battery follows its property. So we can write VA not minus plus 2, and here this is VB. The current is terminating here. So minus VB upon 2. This is the correct equation of current for this particular line. So this is the concept we have used. Let's say let us change the model. Let's say the potential at this point is VA. This is 2 ohm. This is, let's say, plus and minus, plus minus 5 volt. Here again let's say minus plus 10 volt. Here again 5 ohm, and here again VB. Now tell me the direction of the, if I have assumed the current is flowing from VA to VB. Now tell me the equation for this current I. This current is I is originating from VA and terminating to VB, means VA is the independent voltage and VB is also independent voltage, but VE is releasing and VB is receiving. That's why the sign with this VB is minus and the sign with this VA will be plus. Now what for this 5 and 10? So you can see for this 5 volt current is entering from on this plus terminal. But what I have discussed here, current should release. So the battery property is violating here. So you have to write minus 5. For 10, this current is flowing like this. From this plus terminal, the current is releasing. So this battery does not, any property of this battery violates. So you can write plus 10. And minus VB is there, and you know the Ohm's law. I is equal to what? V upon R, and this is what? This hole is what? This hole is the equivalent voltage between these 2 points A and B. And what is the equivalent resistance? 5 and 2. Are they in series or in parallel? In series. So 2 plus 5. That is what? 7. So correct equation for this current is equal to VA minus 5 plus 10 minus VB upon 7. So this is our learning. How to write the correct equation for current. After knowing this concept, we can solve any KCL type of question. Now what KCL is saying? Discuss the KCL again. So KCL means for any node, the sum of all the incoming currents are the equal. The correct statement is, the statement of KCL is the algebraic sum of all the incoming current at any node A is equal to algebraic sum of all the outgoing current from that node. This is, so you can see I1, I2, I3, I4. What are the incoming currents at node A? I1 plus I3. And what are the outgoing currents from node A? That is I. So these are the incoming current, and outgoing current is I4 plus I2. So collectively you can write summation of all the incoming current should be equal to summation of all the outgoing current. This is the KCL. For DC circuit. For AC circuit, we cannot use the term. What? Which term? Algebraic sum. We cannot use this term. We have to use phasor sum. phasor sum. So when we will covering the AC analysis, then we will see what is the phasor. Since for this time we are discussing the DC, so you have to use algebraic sum. Algebraic is very simple, plus minus, but for phasor you have to write magnitude and angle. Let's say 5 at angle 30. This is the current. This is the current for AC, and for DC only 5 ampere. So KCL, KVL, nodal, mesh, these four are the basic pillars for solving any simple electrical network. Okay, now let us discuss the mesh analysis. Mesh analysis. Okay, so if you have to solve this type of problem, okay, so again this is, let's say, plus minus 20 volt, minus plus 10 volt, 5 ohm, 2 ohm, 3 ohm, 1 ohm. If I am saying find the current, find this current I, you have to find this current I using mesh analysis, then just use, first of all you should know what is mesh. What is mesh? Mesh means any closed path where current can move freely, and this closed path cannot be further divided into another closed paths. Let's say I am writing A, B, C, D, E, F, and I am asking how many meshes are there in this network. So you will say, sir, there are 2 meshes only. 2 meshes. What are those meshes? Sir, A, B, E and F. This is mesh number 1. And sir, B, C, D and E. This is mesh number 2. Yes, this is very right answer, because mesh is a loop which cannot be divided into further loops. Means A, B, E, F. A, B, E, F is not divided. This is the smallest form of loop. But if I am saying there is one more closed path, that is what? A and let's say B, C, D, E, F. What you will say to this? You will say this, sir, this is loop. This is loop. This is loop. This is also loop. This is also loop. But what is the difference between mesh and loop? Mesh is the smallest form of loop. Smallest form of loop is what? Mesh. And we have to apply mesh analysis. Getting this point? Now, after identify how many meshes are there, we have to assume some mesh current. Let's say in this mesh I am assuming IA. In this mesh I am assuming IB. In this mesh I am assuming IB. Now I have to write KVL equations. Which type of equations? KVL equations for nodal analysis. For nodal analysis we have used KCL, and for mesh analysis we will use KVL. Getting this point? This is KCL for nodal, KVL for mesh. So before writing the KVL equations for mesh A and mesh B, you should know what is KVL. What is KVL? KVL stands for what? Kirchhoff's voltage law. KVL stands for Kirchhoff's voltage law, which says the algebraic sum, again algebraic sum, because we are talking about DC. The algebraic sum of all the voltage drops in a closed loop is equal to 0. The algebraic sum of all the voltage drops in a closed loop is equal to what? 0. Now, if I have to write KVL equation for, let's say, this mesh A, so this is a battery, no issue, but this is a resistance, and we have to find out the voltage drop across this resistance, and that voltage drop will be what? This current into this resistance, means what? IA into 5 ohm. So what you will say this one? You will say, sir, this is the voltage drop across 5 ohm resistor. Okay, no issue. You have the voltage drop, but what will be the polarity of that voltage drop? This plus minus or this plus minus? Which one is right? So this is the trick. This is the concept. This is very important. So based on your clockwise direction of current, the current is entering from this point. So that this point will be treated as plus, and current is releasing from this point, so this point will be treated as minus. The polarity of this voltage drop, which voltage drop? IA into 5 will be plus here, minus here. These two signs of voltage drop will be useful for writing KVL equation. For this battery given, minus is this, plus is this, okay. And for this resistance, what will the polarity of voltage drop? So you can see IA is entering from here and releasing from here, no issue. But you can see this 1 ohm resistance is common in both the meshes. IB is also contributing for this 1 ohm, but from lower side. So current IB is entering from here and releasing from here. So this is the scenario. Let me draw it again. Let me draw it again. What is the exact scene? So this is your battery. I am drawing the mesh 1 only. No, this is your 1 resistance. This is, I think, here you have 1 battery also. Yes. Okay, so what we have observed so far, so that is 20 volt, 10 volt, this is plus, minus, 20 volt, minus, plus, 10 volt, and the values 5 ohm and 1 ohm, no issue. This is 5 ohm and this is 1 ohm, and this mesh current is flowing like this. We have assumed the first step is assume the mesh current. First step is assume the mesh current. Now write the KVL equation for this mesh way only. So you can write from here. So you can start from any element in the direction of current. Current is moving in the clockwise direction. What first sign you are observing here? What is the sign of this battery? According to this current, that is minus. So you have to write minus 20. Then you have finded out these signs. Okay, yes. What is the sign of this 5 ohm voltage drop? That is plus. So you have to write plus 5 into what? IA, no issue. What is the first sign of this battery? Minus 10. What is the first sign of this resistance? That is plus 1 with which current? IA, 1 into IA. And again you can see for this current is flowing like this, and first sign is plus, and in this loop the first sign is minus, and this minus is due to IB because IB is flowing like this. So you have to write the component of this IB also with minus sign. 1 into IB is equal to 0. So this is your equation number 1. This is your equation number 1. Okay, similarly for mesh number 2 you have to write equation number 2, and after writing these two equations you will have two equations, two unknowns IA and IB. So I am not writing for mesh 2. We will see, but after writing the equation for mesh 2 you will have IA and IB both. Assume you have IA and IB both. And you have to find out the value of I. You have to find out the value of I. Now you will tell me the answer. You can see this is I, okay, and this is IA clockwise, and this is IB also clockwise. But as far as this direction is concerned, this is IA is supporting to this direction or opposing to this direction. I think IA and this I are in the same direction, but IB is opposing. IB is flowing in this branch from B to E, and IA is flowing in this branch from E to B. Means these two currents are opposing to each other, so that the final current will be IA minus IB or IB minus IA. Tell me the final current. IA minus IB or IB minus IA. So magnitude will be same. Let's say anything, any magnitude, but the final answer will be IA minus IB, because this current and IA current are in the same direction, because this is your IA was flowing like this and I was flowing like this and IB was flowing like this. So these are the concepts. For KVL, KCL, and since I am teaching these concepts from very last several years, so I think that these are really silly things for you. Am I right? Since you are the graduates, so I hope I am not making it bore for you. Yes, students, are you still there?
No, sir. Very interesting.
Yeah. Thank you for your
Well,
response.
guys,
Once I visited to
sir,
Sikkim in 2000, I think 18.
Hello, hello.
Actually, sir, in this online teaching, we cannot see our audience, so we cannot get the feedback. After conducting any class, within the 5 minutes, we can get our feedback. What is the flow going on? Which type of teaching quality I am delivering? In the online study, that is the major, I mean, absence of the getting feedback from the audience. Yes, sir. We during when we will start the our course in the proper manner, we will cover all these things. I have prepared the notes for you like KVL, KCL, MES, nodal, theorems are also very important. So after covering KCL, KVL, MES, nodal, we will solve the star delta transformations, because sometimes it is very it becomes very important to minimize the complex circuits, and series parallel combination, series parallel concepts are failed. Series parallel concepts of resistance connections are failed. So we have to use star delta transformation. This is very important, and I have seen various questions on star delta transformation and series parallel transformation. So what will be the my flow during the subject, during our learning? KCL, KVL, mesh nodal. After that, connection of resistance. This is very important. Series connection, parallel connection, star connection, delta connection. Then we will start theorems. So I think if I am asking, let's say this is terminal A, let's say this is terminal B, and some resistances are connected in this manner. So what will be the equivalent resistance? Let's say 1, 1, 1, 1. So what will be the equivalent resistance? Very simple. You can see this one and this one are in series. So 1 plus 1, that is 2. For series connections, resistances are added. So the circuit after solving this step, that is 1 ohm, 1 ohm, and here it will be 2 ohm. Now you can see this is A, this is B. This one, and this one, are they connected in series or parallel? So they are connected in parallel. So what will be the equivalent resistance? 1 parallel with 2. This is the sign of parallel. 1 in parallel with this one, in parallel with this 2. This will be the equivalent resistance. Now maybe some of the students struggle, sir, how you can say, sir, this is in series, how you can identify, sir, this is in parallel? So very simple. Parallel means what? If this is a resistance, the terminal of this resistance is this one, and the next terminal is this. First terminal is this, next terminal is this. If these two connected terminals are sorted, and these two connected terminals are sorted, so here you will find some another terminal, sorted terminal. Let's say this is A, this is B. So if the starting and ending ends of the resistances are connected each other, then we can say this resistance R1 and R2 are in parallel, and the current flowing in parallel resistances are not same, they are different, I1 and 2, until unless the value of resistances are not same. And if the resistances are connected in this manner, let's say this is our resistance number 1 and this is our resistance number 2. If this end is connected to this end only, so these two connections are R1 and R2 are in series. And the another trick for identifying that either they are in series or parallel, just check the current. If the current is same, in both R1 and R2, then your connections are in series. So for series connection, the current is same. For parallel connection, the current is different. The current is different, and the two terminals of all resistances are sorted. First, starting terminals and ending terminals. So this is n number of questions you can find for series parallel combinations. And let's say this type of, if I am giving you this type of question. Okay. Again, this is terminal number A. This is terminal number B. This is 1 ohm, 2 ohm, let's say 3 ohm, 4 ohm, and 5 ohm. What will be the equivalent resistance RAB? What will be the equivalent resistance RAB? So can you use series parallel combination here? No. Then how you can find? So this question cannot be solved without knowing the concept of star delta connection. Without knowing the concept of star delta connection. This is very important. Okay. Yes. So what is star connection? Why type? Someone is dropping some messages. I'm getting the message notification. Okay, no issue. So this is star connection and this is delta connection. Okay. If resistances are connected in this manner, we will call them star connected resistances. If resistances are connected in this manner, we will call them delta connected resistances. So we will discuss star delta and various topics in the next class. So thank you for your attention for this very first class, and I encourage all the students to join our paid course for your preparation. You may contact to Das sir for further information.
Wait, sir. Wait,
Yes.
just a moment, sir.
Yes.
Some students have raised their hand, so I think they have some doubt. So if you take the doubt.
Okay. Yeah. You can unmute yourself and ask me.
Yeah, Preeti.
Hello.
Hello, sir.
Yes.
Good evening, sir.
Yes.
So, sir, there will be like online classes, or we can also start the coaching classes, sir, regular.
Yes, sir. Ma'am, the delivery of the course will be online only.
Okay, sir.
From my end.
See, Preeti, our course is designed only for online. No.
Okay, sir.
And class recording will be there for the paid batches.
Okay, sir.
And this is only for demo, and demo is not recorded.
Okay, sir. Okay.
Demo will continue most probably another 1 day.
Okay, sir. So, but online classes will be, sir, regular basis, no?
Yeah.
Regular basis.
Regular basis.
Okay, sir. Thank you, sir.
No. Anyone have any doubt? Prashant?
Hello.
Yeah, Prashant.
Can you hear me, sir?
Yeah.
So I had one doubt regarding the KCL question. Sorry, KCL question, sir.
Yes, sir. Yeah.
So can I see the screen having that KCL problem, the first one?
Oh, definitely. Is it visible?
Yes, sir.
Yeah. Just let me know where I should stop.
Okay, sir.
Here?
No. Bit. Okay, sir. Here.
Yeah.
So you gave the for VV you gave negative sign, sir. Why is that, sir?
Yeah, very good question, Mister. So the polarity of this voltage VA and VV are positive. Okay, the polarity of these VA and VV are positive. Why I am assuming this VV with negative sign? So you can see here. Okay, this is point A. This is point A. That is the positive. That is the positive VA. And the positive terminal of battery, the tendency of positive terminal of battery is to release the current. Okay. And now current is reaching to this point. Now current is reaching to this point. This is also plus VB. There is also plus VB. But my assumed current is not originating to plus terminal or of VB. It is diverging to plus terminal of VB. That's why this VB I will write with minus sign because it is violating its property, and this VA I will write with plus sign. This is the reason.
Okay, so then if we had started the equation from VV side, then VB would be positive and VA would be negative, right?
Yeah. If you have assumed the current like this, VB and VA, then scene will be changed. this I will be VB minus VA, and you can see here this will again minus 2 upon 2. This will be the current. Yeah.
Okay.
Clear, sir?
Sir, I think there is one current source in between, a voltage source in between, sir. So that shouldn't be considered, sir.
If you are saying that some current source is there between the voltages, like means the model is like this. The model is like this. Let's say the model is like this. Okay. Let's say this is VA, this is VB, this is 2 ohm, and let's say this is 5 ampere of current source. I am assuming. Okay.
Okay.
Now, if I am to write the equation for this I, write the equation for this I, you can see this is a series circuit. This I is flowing through this current source also. So there is no need to write any equation. Write I is equal to 5 ampere only.
Okay, sir.
Getting, because in series the current is same. If current source is there, then your job is easy. You can write the value of this current same as the series connected current source, because the property of the current source is to remain that current flowing through that branch where it is connected.
Okay, sir.
During the course of time, we will discuss all these concepts in detail.
Okay, sure, sir.
Yeah.
Anyone?
Yes. Any further?
Anyone?
Sir, I had one more question, sir. Do we get written notes from you?
Definitely.
Okay, thank you, sir.
Yeah.
Anyone have any doubt? Anyone have any doubt? No doubt. Sir, I think no doubt.
No doubt.
We are crossing the 1 hour. I think it will be auto.
Yeah. So let me add one thing. Thank you for your kind attention, all my dear students. Thank you.
Thank you, sir. Thank you.
Thank you all of you. Thank you. Thank you very much. We are leaving the class.
Yeah. Okay.
Thank you.
Thank you, sir.